Now we'll look at a second way to convert an alcohol to an alkyl halide, and in this particular example it will be specifically an alkyl chloride. So here's the overall functional group transformation. Of course, we're going from alcohol and to an alkyl chloride in this particular example. The overall reaction is going to involve the alcohol with thionyl chloride, which is SOCl2, in the presence of pyridine. Pyridine is the base that's shown here, the nitrogen base. And the products of the reaction are going to be the alkyl chloride, SO2, which leaves as a gas, and then you have this pyridinium salt over here. As I mentioned before, there's a second strategy other than protonating to make the hydroxyl group into a good leaving group. And the first step of that process is always going to be the oxygen attacking some electrophile. In this case, it's the thionyl chloride. The pi bond of the SO bond is broken. So you end up with a new oxygen-sulfur bond here. The pi bond is then going to close back up and displace a chloride ion. So you can see that over here as a byproduct. And then you still have this oxygen-sulfur bond. The pyridine will act as a base and deprotonate this acidic proton here. And now you have a good leaving group on the oxygen. Actually, what's going to happen is this whole thing is going to leave and the oxygen is going to go with it. In order to kick the leaving group off, the chloride ion that was generated during the first step comes back in and displaces this whole group here, and this is done via an SN2 type reaction. Notice that you get the simultaneous formation of an oxygen-sulfur bond, a pi bond, and displacement of Cl- at the same time that this bond is forming between the chloride and the carbon. So overall you end up with the alkyl chloride here, and then you have SO2 as a byproduct and Cl-. SO2 is a gas, as I mentioned, and notice that we're going from 2 entities on this side to 3 entities over here, and one of them is a gas. So this is very favorable in terms of the entropy term of the thermodynamics of the reaction. Since this is an SN2 type displacement, this works best on methyl or primary alcohols, but it can work on secondary alcohols. And that's important because if you remember, when we tried to chlorinate at the position that's shown here, when using HCl as the reagent, we would always end up with the chlorine at a different position because you would get carbocation rearrangement. The nice thing about using thionyl chloride and pyridine is that you can use it on a secondary like the one shown here, but you will not get rearrangement because it does not go through a carbocation intermediate.